If you've watched the two previous lessons, then you've learned about how many molecules or atoms or particles there are in a mole. That's a very large number, 602 sextillion, sometimes called Avogadro's number. You've also learned about how many liters there are in 1 mole of gas at STP. That's 22.4. And you've also learned about how many grams are in 1 mole of any element, and that's equal to its atomic mass. In the case of a compound, the sum of the atomic masses of all the atoms in that compound. Well, we're going to put all that together today, and so here's a chart. This is a chart that I've compiled that hopefully will help you to see the relationship between all these things. And so we have essentially 5 units up here. Well, here at the top, you can see we have Avogadro's number. That's 6.02 times 10 to the 23rd. And we have atoms, molecules, pretty much any particle. Anytime we use Avogadro's number, we're counting very small particles. It could be atoms or molecules or ions or any other teeny tiny particle. And that's how many of those small particles there are in 1 mole. And so that was the first thing that we learned. We learned that connection right here. Now, the second connection we learned about was how many liters there are in a mole of gas at STP. So that's this connection right here, 22.4. And then in the second video in this series, you saw how many grams are in a mole of any element. Basically, it's equal to its atomic mass, like I said. So if we connect all these things together, then we notice that it's possible to have two-step problems. So for example, let's say we had a problem like this right here. It says, what is the mass? A mass is grams of 0.25 liters of carbon dioxide gas at STP. Well, we're going to use that diagram again. Here it is in a small format. And as you can see, we're starting with 0.25 liters of gas. And so here's liters right over here. And we're trying to convert that to grams. And grams is over here, as you can see. So using our mole diagram, how many steps will it take to do that, that conversion? Well, it's 2 steps. The first step is to convert to moles. And then the second step, once we've converted to moles, is to convert to grams. And so if this is our roadmap for converting from one unit to another using the mole concept, then we can say that all roads lead to moles. So when you have 2-step problems, the first step will be to convert to moles. So let's try this. Let's take a look at this here. I'm going to change the color so we can see better on the screen. And so we'll start with the 0.25 liters of carbon dioxide. Now, the formula for carbon dioxide is CO2. So we're going to start with 0.25 liters of CO2. And since the question asks what is the mass, that means down here at the end we're going to have equals grams, because mass is measured in grams. And as we said, this is a 2-step problem, so I'm going to set up 2 separate conversion factors. Now in the first conversion factor, like we said, we're converting to moles. All roads lead to moles. So in the first step, what unit goes on the bottom of the conversion factor? Well, it's liters, because that's what we're starting with. Whatever unit we start with goes in the denominator. And what goes on top? Well, since we're converting to moles in this first step, it's going to be moles. Now, what numbers will go into this conversion factor to make it a true statement? Well, it's 1 mole equals 22.4 liters. Now, if you're not sure where we got those numbers, well, refer back to your mole diagram down here, and that will help you immensely. So you can see that next to the word mole in that diagram, there's the number 1 right there. Well, put the number 1 next to mole in the conversion factor. And the same thing for liters. There's a 22.4 down here next to liters in the within the diagram. So put a 22.4 next to liters in the conversion factor. Well, now we can cancel liters, top and bottom, and if we were to stop right here, we'd be in moles of carbon dioxide, but we don't want that. We want to be in grams of carbon dioxide. So we have one more step. So the unit that goes on the bottom of the next step is moles. Whatever unit we have here always slides down to the next denominator. And what are we converting to? It's grams, so grams goes on top. And so what number goes next to moles? Well, it should be 1, because that's what's next to moles in our mole diagram. And what goes next to grams? Well, it says here atomic mass in our mole diagram. So we need to refer to the periodic table here. So let's take a look at the periodic table squares. And if it's CO2, how many grams are in a mole of that? Well, let's add them up. We have one atom of carbon. Each one of those is about 12.0, so that's 12.0 grams. And then oxygen, we have 2 of them, and each one is about 16.0 if we round that off. So 2 times 16.0 is about 32. And then when we add those together, we see that the total mass of 1 mole of carbon dioxide is about 44.0 grams. So that goes up here next to grams. Make sure that you can do that. The 44 grams comes from those atomic masses on the periodic table. So now we can cancel out moles, top and bottom. And it looks like we're in grams of carbon dioxide. So we're going to have to multiply and divide. We take 0.25 divided by 22.4 times 44, and the answer that we get is about 0.49. So it's about 0.49 grams of carbon dioxide. So that's pretty neat that we're able to find out the mass of a gas just using these conversion factors here. So even though the problem doesn't even say the word mole in it, we use the mole concept to find the answer. Let's try another example. This time we're going to have a question involving NaCl. That's sodium chloride, just normal table salt. And the question says, how many formula units, which is a type of teeny tiny little particle, it's like a molecule of salt, and how many of those are in 29.3 grams of NaCl? So once again, we're going to start what's given to it with what's given to us, 29.3 grams of sodium chloride, NaCl. And it says how many formula units. And so those are like molecules, very, very small particles. So we're going to put formula units. Of NaCl down here at the end. And hopefully we'll have the right answer there. Now let's refer to our mole diagram again to see how many steps we need to perform. Well, if we look at our diagram, we change colors again so we can, this highlights a little bit better. We're starting with grams and we're trying to convert to a type of particle. So here we are in grams over here. And so we're going to have to go to moles first as our first step. And then we're going to have to go from moles to particles, or formula units in this case, using Avogadro's number. So that's our roadmap here to solve this problem. So let's work through that. We're going to do our two-step process here. So I have 2 conversion factors. And so in our first step, it looks like we're converting to moles. You know, all roads lead to moles if we have a 2-step problem. So what unit goes on the bottom? Well, it's grams. So grams needs to go on the bottom, and moles on top, since that's the unit we're converting to. So next to moles, it looks like we have to have a 1. In our road map there, we see a 1 next to mole. And what goes next to grams? Well, the road map here says next to grams, atomic mass. So let's refer to the periodic table for NaCl. It looks like we're going to have to add those 2 together. So we have a number that's very close to 23.0, We're going to add that to a number that's very close to 35.5. And so the total mass in 1 mole of this is about 58.5 grams. So that's going to go next to grams. So grams will cancel, numerator and denominator. So we're now in moles of NaCl, sodium chloride. But we don't want to be in moles. We want to be in formula units, which is a type of particle. So we have one more conversion factor. So what unit goes on the bottom of our next factor? Well, it has to be moles, so it can cancel out with this other mole up here on top. And since we're converting to formula units, that's what goes in the numerator. So we look at our mole diagram, and it looks like next to atoms or molecules or any other little teeny tiny particle, like formula units, we put 6.02 times 10 to the 23rd. And then next to moles, we put the number 1. So we're going to cancel moles top and bottom. And if we look at the problem here, it looks like we're going to divide by 58.5 and then multiply by Avogadro's number. So on our calculator, we take 29.3, divide by 58.5, and then multiply by 6.02 times 10 to the 23rd. And the answer that I'm getting is about 3.02 times 10 to the 23rd. So make sure that you can do that type of calculation. Some students have a little trouble with making calculations involving Avogadro's number or any scientific notation on their calculator. So make sure that you know how to use your calculator with scientific notation before starting the homework assignment or starting a test over something like this. Let's try one more example. And this time we're going to have volume. It says, what is the volume of 1.0 times 10 to the 24th molecules of carbon dioxide gas at STP? So once again, we're starting with that many molecules of carbon dioxide. So that's what I'm going to write down first. 1.0 times 10 to the 24th molecules of CO2. And the question is, what is the volume? Well, you need to know that volume is measured in liters. And so here at the end, we're going to have liters of carbon dioxide. Now let's refer to our mole diagram again to see how many steps we have. And if we look at our mole diagram again, change back to red ink here, we can see that if we're going from molecules to liters, well, here's molecules up here, and the first step to get from molecules to liters will be convert to moles. So our first step, like it seems to always be in multi-step problems, is convert to moles. All roads lead to moles. And then after we're in moles, we're going to convert over here to liters using 22.4. So that's our two-step process. We're going to use that as our plan of attack here. So in our first step, and we're going to need 2 of them, like we said, so I'm going to put 2 conversion factors. In the first step, since we're starting with molecules, molecules goes on the bottom. Running out of room there. Molecules on the bottom. And since we're converting to moles, what goes on top? Moles goes on top. And we use the numbers from the diagram. There's a 1 next to mole. And then there's a 6.02 times 10 to the 23rd next to molecules. And so molecules can cancel top and bottom. And now we're in moles of CO2. And we have one more step. We want to get from moles of CO2 to liters of CO2. So it looks like our next step is to put moles on the bottom of the next conversion factor and liters on the top. And so what numbers go in here? Well, look at the road map again. There's a 22.4 next to liters, and there's a 1 next to moles. So we can cancel moles. It looks like we have to do some multiplication and division. So we're going to type in 1.0 times 10 to the 24th divided by 6.02 times 10 to the 23rd times 22.4. And the answer I'm getting this time is very close to 37. It looks like the answer is very close to 37 liters of carbon dioxide. And so that's our answer. And so in today's lesson, the goal is to be able to use this mole diagram or something similar to it to solve multi-step problems. And so we're not just converting from moles to liters or grams to moles, we're converting from grams to moles and then to something else, atoms, molecules, liters. And so we have several units that we're able to convert here using this mole diagram and the concept of the mole.